Okay, for the solving quadratic worksheet that you guys were supposed to do for homework, we'll start with the difference of two perfect squares. Again, you should have taken notes on example 1 and example 2. So now we're going to go into the packets, and I asked you guys to do 3 questions. The first one, just like example 1, x squared minus 100. Solving for x squared, we're thinking about factoring. No common factor. Difference, meaning subtraction, of two perfect squares. Yes, by definition, this factors into two binomials. The positive term is x squared. Its square root is x and x. By definition, my signs are different. And the square root of 100, which is the negative term, comes second, and that's 10. All right? So again, we get 0 on one side, which we have. We factor, which we did. And then set each factor equal to 0 and solve. Subtracting 10 from both sides, I get x is equal to a negative 10. Adding 10 to both sides, I get x is equal to a positive 10. My answer. All right, I move to question number 2. Question number 2, get 0, again, solving for x squared. So we're trying to get x from x squared, so we got to get 0 on one side. I'm going to subtract 9 from both sides to get that done. So I have x squared minus 9 equals 0. All right? There is no greatest common factor. This is the difference of two perfect squares. So it's going to break up into two binomials. Signs are different. The x squared is the positive term. Its square root comes first, x and x. The 9 is the negative term. Its square root comes second, 3 and 3. Set each factor equal to 0. And solve. And we're done. All right, and then kind of the challenge question here is, this is going to be two factoring techniques. First of all, we have an x cubed. That tells me we can have up to 3 possible answers. Okay, the first thing we do whenever we're trying to solve for anything that's greater than x to the first is we try to get 0 on one side, and we have that. And then we go through our factoring techniques. First, we go through GCF, and there's definitely a GCF here. That GCF is going to be 3x. What's left is going to be, if I take a 3x out of here, or what do I multiply 3x by to get 3x cubed? That'll be 3x squared, minus, what do we multiply 3x by to get 75x? Oops, sorry, my fault. What do we multiply 3x by to get 3x cubed? It's going to be x squared, my fault. And then what do we multiply 3x by to get 75x? That's going to be 25. And then that's set equal to 0. So then we have 3x. This is now the difference of two perfect squares. So by definition, we're going to break that up into two parentheses. Signs are going to be different. The x squared is the positive term, so we have x and x. The 25 is the negative term. Its square root is 5 and 5. And then, according to step 3, we set each of the factors, 1, 2, 3, equal to 0. So 3x equals 0. X plus 5 is equal to 0. And x minus 5 is equal to 0. No big deal, just like we normally do. Here, divide by 3, x is equal to 0. Here, subtract 5 from both sides, x is equal to a negative 5. And here, add 5 to both sides, and we're going to get x is equal to 5. And there are your answers for the difference of two perfect squares factoring worksheet, solving worksheet.